Hey class, welcome back to Right Triangles and Trig and the lesson on Pythagorean Theorem. We're going to move on with our next video. Now, in the previous video, we learned about finding the hypotenuse of a right triangle, finding the leg of a right triangle, and calculating distance of a right triangle, like inside right triangles. And so what we're going to work on in this video is learning how to classify a triangle. Now, if you recall from the previous lesson, if you haven't watched that, shame on you. But if you recall from the previous lesson, we remember that if we have a triangle and the sum of the squares of two of the sides is equal to the square of the third, we have a right triangle on our hand. Okay? But then I should beg the question, beg. What if they weren't equal? So what if those distances were not equal? Okay, so this is interesting. What if the square of the lengths of the longest side was bigger than the square of the lengths of the other two sides, right? So in every triangle you should see, well, we have a longest side. Now what would happen if the square of the longest side was bigger than the sum of the other two squares? We have what is called an obtuse triangle. An obtuse triangle. Why do you think we would call that an obtuse triangle? Because we have an obtuse angle. Good guess. Way to go. Cookie for you. All right, so why is that an obtuse triangle? Because we have an obtuse angle. Remember, an obtuse is bigger than 90. Acute is smaller than 90. Cute little angle, smaller than 90. Obtuse is bigger than 90. Right is 90. True? True. All right. So in the case of a third side, the longest side, the square of the longest side being greater than the sum of the squares of the other two sides, we have an obtuse triangle. Well, what if that wasn't the case? What if we had the situation where the square of the longest side was smaller than the sum of the square of the other two sides? What would happen if the square of the third side, the biggest side, is smaller than the square of the other two sides? Then we would have an acute triangle. So what is an acute triangle? It's when all three angles are less than 90. All three angles are acute. We have no angles that are 90 or bigger. It's acute. It's a cute little triangle. Yeah, all the angles are acute. Okay, so that's vocab, man. Know your vocab. So we have an acute triangle, an obtuse triangle, and of course we have our right triangle with a right angle. Okay? So that's the notes. Now what are we going to do for the rest of this video? Apply the notes, fool! So we're going to do that. Now here's a few examples, but we'll start with just one at a time. A triangle has side lengths 6, 11, and 14. Is it acute, obtuse, or right? Now how are we going to test it? We have to look for the longest side. Of 6, 11, and 14, I hope you know 14 is the longest side. Okay, so what are we going to do? We're going to test 14 squared, and we're going to compare it to, is it bigger, smaller, whatever, equal? And we're going to compare it to 6 squared plus 11 squared. Okay, so that's the setup. Is it going to be equal to, bigger than, or smaller than? Okay. Now, if you don't know 14 squared, use a calculator like I'm doing right now for some reason, because I did know it's 196. What's wrong with me? So we have 196, and is that going to be bigger than or smaller than or equal to 36 plus 121? Okay, well, 36 plus 121 is 157. So we are comparing 196 to 157. Okay? Now, which one's bigger? Good job, class. 196 is bigger. That means the square of the largest side is bigger than the sum of the squares of the other two sides. And which triangle is that? The square of the longest side is bigger than, obtuse. Right? Isn't that a neat way to remember that? Bigger than, obtuse, obtuse. So in this case, we are going to have an obtuse triangle. Isn't that cool? Yeah, good job. Next example. I need more practice. Good, me too. So, is a triangle at side length 7, 8, 9 acute, obtuse, or right? Well, let's figure out what's the biggest side between 7, 8, and 9. The largest side, of course, is 9. And so we're going to set it up. Is 9 squared, is that going to be bigger than, smaller than, or equal to 7 squared plus 8 squared, right? So 7 squared plus 8 squared. So hopefully we know 9 squared is 81, 7 squared is 49, 8 squared is 64, and you should already be able to tell, without even doing addition, we should already be able to tell that 49 and 64 is going to be bigger, right? So boop, 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 boop. So that means 81 is smaller. That means the sum of the longest, or the square of the longest side is smaller than the sum of the squares of the other two sides. So which triangle fits that description? Of course you know. That's a cute little triangle. So this one is indeed acute. So that's an acute triangle. All right, that's how we're going to figure that out. Next example. Now the question is a little bit different, but the process is the same. A triangle has side lengths 16, 48, and 50. Is it a right triangle? Explain. Okay, so let's figure it out. What is the longest side? The longest side is 50, so we're going to set that bad boy up. Okay, so we get 50 squared, and we're going to compare it to some pretty big numbers here. 16 squared plus 48 squared. Okay, so now we're going to do some tests. Check this out. Mental math. 5 squared is 25. 10 squared is 100. So 25, 0, 0. So 50 squared is 2,500. Okay. 16 squared, is 256, I think. I'm testing. Did I remember? Yes. So that's 256. 48 squared is something out of my memory. So calculator, 2304. Okay, so that's the setup. Which is bigger? Is the square of the longest side bigger, smaller, or equal to? And so now we have 256 plus 2304. And we find out that is 2560. Okay, so we are now comparing 2500 to 2560, which is bigger. Okay, hopefully you see that 2560 is bigger. That means that's the case here, and that means that's the case here. So we have an acute triangle. So no, it is not a right triangle. It is an acute triangle. So the answer is no, it's acute, because the square of the longest side is smaller than the sum of the square of the other two sides. So no, it's acute. Okay. Here's another good, I like this example. You're going to love it. So here's another example. A triangle has side lengths 85, 84, and 13. Is it a right triangle? Explain. Well, let's find out. What is the largest side? The longest side is 85, right? So we're going to be testing that. So is 85 squared bigger than, smaller than, equal to 84 squared plus 13 squared? So hopefully you can see we're going to have some pretty big numbers here. The first, of course, is 85 squared, and that is 7225. So 7225. Is that going to be bigger than, smaller than, or equal to? 84 squared is 7056, and 13 squared is 169. Okay? So that's the question. Is it bigger than, smaller than, or equal to? So let's add our two lengths together, and guess what we're going to have? 7225 compared to 7225. What's going to happen? Oh, they're equal. They're equal. They're equal. What does that mean? So the square of the longest side is equal to the sum of the squares of the other two sides. What does that mean? Bam! We have a right triangle. So is it a right triangle? Yes. Yes, it is. You want my explanation? Look, it's a right triangle. More importantly, remember the word Pythagorean triple. We've got the old 13, 84, 85 Pythagorean triple on our hands. I don't know if that's a good old Pythagorean triple, but that's a helpful number to remember. Okay? So 13, 84, 85. Yay. So that's it for new stuff. Let's do a quick quiz. I love this question. It's going to keep you on your toes. All right, so here's a neat question. Can three segments with length 4 centimeters, 6 centimeter, and 11 centimeter be assembled to form an acute triangle, a right triangle, or an obtuse triangle? Now watch this. Hopefully you know the answer by now, but watch this. Look at the explanation for, let's say, D. 4 plus 6 is less than 11, so the three lengths can form an acute triangle. Well, it's saying that 11 is greater than 4 plus 6. Well, that has nothing to do because we're talking about squares. So it can't be that. We're not talking about squares. It says this, 4 plus 11 is greater than 6, and 6 plus 11 is greater than 4, so it can form an obtuse triangle. Again, we're not talking about squares. There goes that. Now this one says 4 squared plus 6 squared equals 11 squared. Is that true? Is that a true statement? 4 squared is 16. 6 squared is 36. 11 squared is 121. That ain't true. That ain't happening there. So what must the answer be? It's got to be answer B. But do you remember? Do you remember from long ago? The third side must be between the sum and the difference of the other two sides. Okay? The third side must be between the sum and difference of the other two sides. Okay? So that's old stuff. The sum and difference of the other two sides. That's an important thing to remember. So clearly when we look at 4, 6, and 11, 4 plus 6 is 10. So that's already out of bounds. No, it can't form a triangle at all. So we know that B is the appropriate response. And I wanted to keep you on your toes with that question. That's a great question at this time of year to remind us of what goes on with triangles. So anyway, that is it for the lesson on Pythagorean theorem. I hope you enjoyed it. We now know a whole bunch of stuff, and we're going to keep going trig later. See ya!